Welcome to the Unreal Engine 5 C++ multiplayer shooter course. In this course, we'll be creating this multiplayer shooter game completely from scratch. As you can see here in this test session, I have 19 players from all across the globe playing my game with me. In this course, we'll be creating a fully functional multiplayer game with complete networked functionality, optimized for a smooth gameplay experience, capable of hosting many different players connected via online sessions. We'll start the course by creating a multiplayer plugin that can be added to any Unreal Engine project to enable multiplayer. This makes creating multiplayer games easy, as our plugin will handle creating sessions, finding and joining sessions, and destroying sessions with an easy-to-use interface that can be customized for your particular game. We'll learn all about the Unreal Engine Online Subsystem, a codebase for managing connections to various services like Steam. Our plugin code will work for any of the services supported by Unreal Engine's codebase, and we'll use Steam to quickly get our sessions working and connecting with other players. You'll join an active Discord community where you will find other students and test each other's games across the internet so you can make sure your game project is working properly in true multiplayer. You won't have to test your game alone. We'll make sure you have testing partners. The plugin section of the course is independent of the actual game project. So if you want to jump into multiplayer game programming and just start making the actual game, you can download the plugin, and I'll show you how to add it to your project to enable Steam sessions right away. We'll then create a fresh Unreal Engine 5 project and enable our plugin. With some quick multiplayer tests to verify that networking works, we'll create a new character class and add a mesh and implement basic movement functionality, including crouching, jumping, aiming, and aim walking, all programmed for multiplayer, of course. We'll then create our weapon classes and functions to equip weapons. We'll handle all combat-related behavior in a combat component to keep character and combat functionality organized. We'll learn how the game works on the server and clients, and learn about network roles and authority and how gameplay logic must be programmed to work in multiplayer. Each step of the way, we ensure that the server maintains authority over all important gameplay logic like health, damage, and ammo, so our game can prevent players from cheating. We'll create multiple weapon classes, implementing both hit-scan weapons and projectile weapons. We'll create assault rifles, pistols, submachine guns, sniper rifles, rocket launchers, grenade launchers, shotguns, and throwing grenades. We'll use projectile movement components, taking advantage of Unreal's built-in replication behavior for projectiles, and apply damage directly with hit events, and apply radial damage with a fall-off for explosive weapons. We'll implement random weapon scatter for bullets, and we'll see how this works for all weapon types, including shotguns. We'll also ensure that random scatter is consistent between all machines, so you'll always get an accurate hit when you should. We'll implement dynamic crosshairs that spread and shrink and turn red when aiming at another player. We'll use aim offsets and inverse kinematics for weapons, so our hands are always placed correctly on the weapon, and make sure that the weapon is always oriented in the correct direction where the bullet is firing. And our weapons will eject bullet shells with physics and sounds. We'll then discuss Unreal Engine's class framework and how engine classes relate to multiplayer, and discuss the roles of each class and where data and functionality should be programmed in a multiplayer game. We'll discuss the difference between the game mode and game mode base classes, and how the game mode has more functionality designed for matchmaking, including the concept of match state. We'll make use of the match state and even create our own custom match states so we can have different stages of our match, including a warm-up stage where the player can fly through the level while waiting for the warm-up timer, and a cooldown state where we'll display the name of the winning player and the player's score. We'll create a working countdown timer managed by the game mode, and we'll learn how to sync the client's running time with the server's time, so all players see the exact same number at the same time. We'll implement player eliminations and respawning in the game mode, as well as assign points when the player scores and store the player's score on the player state class. We'll create a game state class for keeping track of the top scoring player, as well as team scores and top scoring teams. Elimination is going to be awesome in this game. We'll make an elim bot that spawns when a player is eliminated and will beam the player up, dissolving the character with a dissolve material that we'll create from scratch and change at runtime dynamically. We'll create pickups to buff the player, including health, shields, jump and speed buffs, and we'll handle all this behavior on a buff component. We'll make a pickup spawner class that will respawn pickups after a randomized time period. We'll display all relevant game data on the HUD, including a health bar, a shield bar, score and defeats, grenades, weapon ammo, and carried ammo, and we'll drive these values from C++ with an efficient system that's event-based, updating the HUD only when a variable changes rather than checking for it each frame. From there, we'll discuss lag and go over the various lag compensation techniques used by AAA shooter games, and then we'll implement them. We'll use client-side prediction to make the experience quick and responsive in the presence of extremely high lag. We'll learn how to simulate lag both in the engine and in packaged builds, so we can test the game in the harshest of lag conditions. We'll then create a server-side rewind algorithm, an advanced technique used by most of your favorite AAA shooter games to ensure that players always get credit for their hits, even in high lag situations, by storing a history of player information and rewinding time on the server to verify hits, giving players credit whenever they score a valid hit on their machine. We do this for hit scan weapons and projectiles. We then discuss the pros and cons of server-side rewind and how always giving credit for shots can come with the fabled dying around a corner problem, where a laggy player scores a hit, and by the time the other player reaches cover, they die around a corner. We then learn how to limit server-side rewind based on a player's ping, so we can eliminate this problem. Our lag compensation algorithms will all go on to their own lag compensation component to keep them encapsulated and organized. We'll then discuss cheating and how a player can cheat and how to prevent it. And we'll learn that we've architected our game to prevent cheating the whole time, as well as how to perform validations on data sent to the server and even kick players attempting to send bad data. We'll implement a Teams game mode and finally capture the flag before we wrap up the course. We'll be packaging and testing our game all throughout the course, and frequently testing with real players to make sure things work in multiplayer every step of the way. You'll have a complete multiplayer game, making full use of Unreal Engine's multiplayer codebase to connect and play with other players across the internet, and you'll learn the methods used to make a fast-paced, competitive shooter reliable and performant. We optimize for low bandwidth and maximum network performance, and by the end of this course, you'll have more than enough skills to implement any type of multiplayer game you want. If you can do a shooter game well, you can do any game, because shooters are the most difficult, as performance is critical with a fast-paced, competitive game. Each lecture has its own GitHub commit, and I'll show you how to see code changes for each individual lecture, so you can always check back with the code when you have issues, and you'll be connected with an active Discord community so you can discuss your issues with other students and myself, and we'll make sure you get your project working if you ever get stuck. You don't have to be an expert to take this course. Basic C++ knowledge or understanding of a similar language like C# or Java will do. If you've already taken my Learn C++ for Game Development course, you're covered. And it'll help if you've taken at least one of my other Unreal Engine C++ courses, either Unreal Engine C++ The Ultimate Game Developer course or Unreal Engine C++ The Ultimate Shooter course. If you've taken either one of those courses, you're more than ready to dive in. But if you haven't, you'll still be able to do this course if you know some basic C++. Variables, functions, pointers, and classes. Those types of things. I haven't even told you all the features we cover in this course. The skills you learn will greatly enhance your capabilities for your gaming career and earn you huge points if you're trying to get a job in the gaming industry. Just mention server-side rewind in an interview, and people are suddenly very interested in you. So if you're ready to make multiplayer games in Unreal Engine and create the most impressive game project you've made so far, get ready to jump in and create this Unreal Engine 5 C++ multiplayer shooter.